Coronication Day 3, where I am handling my first topic request from a student who had emailed me. He is an ambitious little bugger. He's in Goal 5, and he had problems specifically with polynomial long division problem type 2. I would have made this video yesterday, but there were problems. So when we're looking at polynomial long division, the biggest thing that you want to be doing is they tend to give it to you in this kind of format. You can see it because these are screen grabs from the software, where they have one giant polynomial, poly meaning many nomial meaning terms. So many terms. See, we have an x cubed, an x squared, an x, and a number. That means there's a lot of terms here divided by this polynomial. Technically, it is a binomial, meaning it has two terms. What we want to do though is, because they have it set up the wrong way, we need to actually make it to set up like actual honest to God long division from middle school. If you can remember your long division from middle school, that can make things a little bit easier. But if not, this will act as a good refresher. As I recall, you did polynomial long division problem type 1 right before the coronication hit, so some of this might look a little bit familiar to you. And keep in mind, this is problem type 2. There's like a total of 4 or 5 problem types. One of them, I forget which one, is on the DSA, so you kind of want to burn through all of them. It's all the same format, it's all the same setup. You set up your long division, you go through the steps, it's exactly the same. The reason why it's divided into different types is because your, what do you call this? This is your quotient, not that I can type, and your remainder are going to be two different things. So let me get my text box set up because you can know we're going to take up kind of a lot of space. All right. Blah, blah, blah. Okay, so that way I have something to type into. We're going to start up here. What we want to do is we're going to be looking at this x3, and we want to force it and do something to it to look like 6x cubed. So we'll start with looking at the numbers first. I am trying to force my 3 to turn into a 6. So what do? I multiply by 2. Okay, so far so good. Next, I need to get my x to look like an x cubed. How do I do that? I multiply by x squared. So that's my first part. 2x squared is going to be the first part of my answer. The question now becomes, what does that actually look like? Let's make this font a little bit bigger. So 2x squared times 3x is 6x cubed. That's kind of the whole point. Next up, I need to do 2x squared times my 4. So I'm doing it to both pieces of this binomial. 2x squared times 4. 2 times 4 is -8. And then the x squared, it doesn't have a mate here, so it's just x squared. All right, so far so good. And if you look very carefully, you'll see that everything lines up. The x cubed is over the x cubed. The x squared is over the x squared. Again, as you start getting into type 3, type 4, they don't always line up. You got to be careful of that. And basically, you're kind of playing a matching game by the end. So the one thing we need to do for all of this is we need to subtract. This makes more sense when I'm doing it in the notebook paper, but because in long division from, middle and elementary school, you have to subtract the number. Here we have to do the same thing. So we have to subtract, which means the signs flip for everything. That takes a while for students who don't remember their long division to kind of get the hang of. So what actually happens, let me get into a new layer here for a second. Brush tool. What actually happens, this completely disappears. Huzzah, happy days. Next up, we actually have to do the -11. Oh, computer, be mean to me. Don't be mean to me. So what is -11 plus 8? -11 plus 8 is -3x squared. And now we're back to start. The next piece drops down, so it's -14x. All right, and now we're going to be working back up here, because now that's 3x squared. We have to force our 3x to look like a -3x squared. So what are we going to multiply by? -1. That makes sense because we need the +3 to become a -3, and then we need the x to become an x squared, so -1x. Or if you're lazy like me, you just write -x. So we're going to take that and now multiply, computer, I swear my computer hates me since the communication started. Now you're going to take that information and multiply it here. So what is negative x times 3x? That's negative 3x squared, which is what we were looking for. And then negative x times negative 4 is positive 4x. That's what we ended up getting. So now we actually have to do the computer. I'm not even recording for 5 minutes. Why are you overclocking? Now we have to subtract. So subtract. That's going to be a little bit big, isn't it? Question mark. All right, let's see how it works out. I'm having a moment where I'm doubting my own math because I am doing this in my head. So escape, and then here and brush tool. So now the whole point, our 3x squareds now disappear. That was kind of the whole point. We got what we wanted. And now we're going to be looking out over here. So let's see here. If I drop down the negative 14x and then negative x is going to be plus 4, subtract is negative 4. So that's right. Oh, yes, yes, this does work out. Negative 18x. And you'll notice you heard me muttering to myself, MT, as I was trying to figure this out, because for a hot second I was doing the math wrong in my head and I thought it wasn't going to divide evenly, but we got lucky. It did. All right, and then the plus 18 drops down. So that part's all set. Now we're going to be back up here because, again, we're trying to get that 3x to look like negative 18x. So what are we multiplying by? Negative 6, right? Negative 6 times 3 is negative 18x. Yep, that makes sense. So, computer, we have our negative 18x because that's what negative 6 times 3x is. And now what's negative 6 times negative 4? That is going to be positive 24, okay? And I did not give myself enough room. There we go. Computer, lag later. Now we're going to go through the effort. We're going to, most important step, everyone forgets, subtract. Flip your signs. Now that we have that taken care of, we now know that, brush tool, the 18x's cancel out, which is our win state, and now we want to figure out what the actual remainder is. Because if you notice, come back computer, if you notice, 2x squared minus x minus 6, that looks very much like a quotient. We got to figure out our remainder. What is 18 minus 24? Negative 6, and that's going to be our remainder. Did I have enough space? No, I didn't. I'll just put r. It's going to be our remainder. So we have our quotient, 2x squared minus 6x, and we have our remainder. I'm going to do one more to make sure you're comfortable with it, MT, and then we're going to move on, hopefully, and start setting up for my live stream. So next up, what do we have? We are going to have up here is going to be our quotient. Did I give myself space? Good. And then down here is going to be where all of our work goes. All right. So what do we start? Computer. So what do we start with? We need 6x squared to look like 18x cubed. 6 times what is 18? 3. X squared times what is x cubed? X. Okay, not so bad, relatively painless. So 3x times 6x is 18. X times x squared is x cubed. That's what we wanted to. And now we, and now what do we have? We have 3x times 5x. So that's 15x squared. That mostly lines up. Doesn't perfectly line up. There we go. Okay, so now we're going to do what we've been doing. Most important part, we are going to subtract. And how did the tabs screw with me that bad? There, all lined up. So what does this do for us? The 18 and the minus 18 cancels out, which is kind of the whole point. That's what we're trying to shoot for. So then, what is that? What is 9 plus 15? That is 24x squared. 24x squared. Let's put that over. And then the minus 8x drops down. And now we're going to be looking back at our quotient. So now we got to ask ourselves, 6x squared times what gives me 24x squared. So 6 times what is 24? That is 4. All right. X squared, to get x squared, well, we're done. And this is why it's problem type 2. Problem type 1, everything worked out and it was the exact same answer, the exact same format of an answer every time. You can see over here our quotient is a trinomial. There's 3 terms, the 2x squared, the x, and the 6. And I can already tell over here my answer for this next problem is just a binomial because you have the 3x and the 4, and I already can see into the future and know that that's not going to divide any more evenly, which means my quotient is going to look a little wonky, and that's what they're trying to train you to get used to. So let's see what it actually susses out when we go through this. So 4 times 6x squared is, of course, 24x squared. Not that I can type. And then 4 times 5 is negative 20x. And now we just need to subtract, which I didn't actually do. Hang on. So subtract. Flip all of your signs. And now we're all set. So we are left with the brush tool. What? No, not the brush tool. The brush tool does the crossing out because the 24s completely disappear. Oh, my shiznits. The 24s completely disappear, and now what are we left with? Negative 8 plus 20. What is negative 8 plus 20? That is going to be 12x, and then the minus 3 drops down. Now, here's where I told you that things get a little bit wonky. Is there any version of 6x squared that can be multiplied in order to force it into a 12x? We can do 6 times 2 to get us 12, but we can't do an x squared to an x because that's inherently smaller. So what that means is this entire piece here becomes my remainder. So now I have a binomial for an answer, 3x plus 4, and I have a binomial for a remainder, 12x minus 3. That's the new part. That's what makes this problem type 2. I've gone through 2 examples. If you're still struggling with this, send me an email and I will go through. As you can see, I have a couple more examples to go through. Hopefully this helps. See you, fingers crossed, in the live stream.